What was the powerful breathing secret that monks and yogis discovered thousands of years ago? It turns out that 40 years ago, 3 doctors discovered this secret using scientific monitoring equipment and observing cosmonauts, monks, and yogis while they meditated. They called it resonant breathing. It has been shown to dramatically improve health and quality of life in so many ways. There are peer-reviewed studies showing benefit with heart health, digestion, blood pressure, stress management, sports performance, asthma, PTSD, and sleep, just to name a few. And they're discovering even more beneficial uses all the time. The story of the discovery began 40 years ago when Dr. Richard Gevirtz and Dr. Paul Lehrer, 2 young PhD psychophysiologists studying biofeedback, went on a research trip to the Far East. They had decided to study the amazing control that monks and yogis had over their autonomic nervous functions when they meditated. These masters could sit quietly and easily increase their systolic blood pressures from 80 to over 200, then bring it back down again. They could do similar feats with their pulse. Dr. Lehrer even studied one monk who could cause one of his ears to become red and warm, while at the same time making the other ear become pale and cool. This monk could then switch ears. The 2 doctors never did figure out how he did it. They used a polygraph measuring heart rate, blood pressure, skin temperature, and skin conductance to observe these masters. The subjects were asked to meditate themselves into a state of deep relaxation with a feeling of total well-being. The researchers noticed that whether they were in Thailand, India, China, or Japan, the meditators would all breathe at a slow, constant rate, and they also saw that every time the meditators were asked to go into this state, their breathing rate stayed within 1/2 breath per minute of the rate they had used in the last session. Different meditators did use different rates, but they were almost always in the 4 to 7 breaths per minute range. When Doctors Gevirtz and Lehrer returned to the States and began to try to figure out a way to find the ideal slow breathing rate, they came across the work of a Dr. Tashilov, who had worked with cosmonauts in Star City. He had unexpectedly come across the power of slow breathing while routinely monitoring the heart of a cosmonaut in his space capsule. He noticed that a couple of times a day, the cosmonaut's heart would suddenly slow down and develop wide swings from the fastest to the slowest heart rate in an oscillating rhythm. Doctors call this sinus arrhythmia, and it's a normal, healthy rhythm, but it was unusual to see it expressed to that degree. He asked the cosmonaut about this, and it turned out that the cosmonaut had been meditating. Dr. Tashilov then began experimenting with breathing rates that produced a maximal amount of sinus arrhythmia. At that time, doctors in the US were just beginning to measure and test the significance of something called heart rate variability, which was basically just a sophisticated mathematical representation of the respiratory sinus arrhythmia that Dr. Tashilov had seen in his cosmonaut. Heart rate variability basically shows the average beat-to-beat distance in milliseconds of all the previously recorded heartbeats, expressed as either the standard deviation or the root mean square. Scientists knew that in pretty much all animals, the heart rate would speed up when they inhaled and slow down during exhalation. It's commonly felt that this is an evolutionary modification to conserve energy, because it is most efficient to circulate the blood through the lungs when they are oxygen rich during the inhalation phase, and as little blood as possible during the oxygen poor exhalation phase. In humans, this can save us over 350 million heartbeats in our lifetimes if we stay healthy and maintain good heart rate variability. Scientists had also noticed that chronic illnesses like coronary artery disease, heart failure, high blood pressure, and diabetes, as well as decreased longevity in general, were strongly associated with a decrease in sinus arrhythmia and heart rate variability. Before I can explain how resonant breathing works, you have to understand just a little about how the actions of our body that we don't consciously control all the time, like breathing, heart rate, blood pressure, sweating, body temperature, and digestion, are controlled. They're controlled by a special branch of the central nervous system called the autonomic nervous system. This system is divided into two branches, the sympathetic and the parasympathetic. They're generally complementary to each other. So, for example, if the sympathetic nervous system increases something, like pulse, the parasympathetic system will decrease it, and vice versa. The sympathetic nervous system almost always can override the parasympathetic system, as its main function is to deal with threats to our life and thus control our fight or flight response. The parasympathetic system controls functions that have lower priorities, like digestion, mating, and sleep. In the case of heart rate, as I said, the sympathetic system increases it, and the parasympathetic system slows it down. Researchers had found that in people with low heart rate variability, the problem was almost always decreased parasympathetic braking activity. Doctors Gevirtz and Lehrer began observing experimental subjects while they breathed at various rates from 4 to 7 breaths per minute, and tried to maximize both respiratory sinus arrhythmia and heart rate variability, trying to find a breathing rate that would maximize both. They called this the resonant breathing frequency, or the meditator's point. It turned out to be different from person to person, with, for example, tall people usually having a lower resonant rate. But whatever the rate turned out to be in adults, it generally stayed pretty stable, not changing from year to year. Here's Dr. Gevirtz finding the resonant frequency for one of his graduate students with the polygraph setup that he uses.
Okay, so you see, for one thing, this very nice sine wave in the heart rate. His heart rate is going from 57 beats a minute up to 70 beats a minute in each breath cycle. All right, so he's showing these really big peaks and valleys, which we like to see. It's a pretty nice looking sine wave for the heart rate. That means that the parasympathetic nerve is really taking over and doing that braking the way it's supposed to. His hands are getting warmer. We all know that that means more relaxation, and his hands are getting drier. So during this particular phenomena, what we see again and again and again is that kind of split where hands get warm and dry in a continual basis. And as people get better at it in practice, they can, within 3 or 4 breaths, they can switch into that mode very quickly. So for the athletes, we need them to be so good at it that before they serve a tennis ball, before they go up to bat in baseball, before they do a gymnastics routine, they have to be able to get into this state very quickly. And we train them to do that.
Since our trio of doctors discovered resonant breathing, the Russians call it coherent breathing, hosts of other researchers have done studies where they would have people breathe at their resonant frequency, usually for about 10 to 20 minutes per day, and then observe how it might affect various medical, psychological, and stress-related conditions. Among the host of benefits that have been found, one unexpected benefit was improvement of the baroreflex that most experts felt could not be improved. This is a reflex where pressure sensors in our aorta and carotid arteries send constant messages to the brain about our blood pressure. Normally, when the blood pressure gets too high, the brain sends messages back down the vagus nerve to slow down the heart in order to decrease the pressure. In many of the same illnesses in which we see low heart rate variability, like high blood pressure, heart failure, and diabetes, the baroreflex is also found to be poorly responsive. That is, the heart rate drops much less for a given rise in blood pressure than it would drop in a healthy person. It turns out that regular practice of resonant breathing, which maximizes parasympathetic braking activity, was able to improve the baroreflex as much as 30%. Dr. Gevirtz has postulated that the parasympathetic nervous system is just like a muscle that weakens when it is not used. In people who are under constant stress, the sympathetic nervous system is constantly active, shutting down the parasympathetic for long periods. So the parasympathetic nervous system is underused and begins to atrophy. He postulated that resonant breathing was like lifting weights for the parasympathetic nervous system. It allows it to build up its strength back, which makes a good tonic for the modern stress-filled lifestyle. Dr. Gevirtz's most successful work has been to use resonant breathing to treat pediatric irritable bowel syndrome and functional abdominal pain. He has achieved high rates of total remission using 20 minutes of resonant breathing daily. Here's a clip of Dr. Gevirtz talking about his work with children.
So we get about 3,000 kids a year are referred to our children's hospital in San Diego with this problem. This is after going to a primary doctor. Then they go to the gastroenterologist, and we get about 12 referrals a week in our clinic for these kids, and I'd say 80% of them we get completely better in about 3 or 4 weeks. And these are kids that have been out of school, homeschool, going to emergency rooms. It's an incredibly powerful way of affecting the parasympathetic nervous system. It's hard to believe it could be that powerful, but it really is.
Performance anxiety in sports and the performing arts causes sympathetic nervous system stimulation, the fight or flight response. In the absence of counterbalancing parasympathetic tone, this can lead to a lack of coordination in opposing muscles by depressing the nerve receptors in muscles that allow the brain to detect changes in muscle length and limb position. In a case study, Dr. Gevirtz used resonant breathing to improve a golfer's performance by 15 strokes after just 10 sessions. He points out that the entire U.S. Olympic girls gymnastic team is using resonant breathing before performing their routines, as are many other professional and non-professional athletes. There's another exciting frontier of resonant breathing that is just beginning to be explored, and that is the direct connection of the heart to the brain. and only 20% of the nerve fibers that carry information from the brain to the heart go from the brain, while 80% carry information from the heart to the brain. And more importantly, these messages from the heart are perceived strongly in the region of the brain that controls mood and depression. The electrical waves that are generated by the nerve impulses from the heart can be perceived on an electroencephalogram. The electrical waves that come from the heart are called heartbeat-evoked potentials. Resonant breathing dramatically increases the strength of heartbeat-evoked potentials and has been shown in studies to improve mood and decrease depression scores. In another study, it also increased a person's ability to sense their own pulse. Here are some other conditions for which there are peer-reviewed studies showing a benefit from resonant breathing. Asthma, chronic obstructive pulmonary disease, fibromyalgia, hypertension, chronic muscle pain, congestive heart failure, irritable bowel syndrome, angina, preterm labor, pregnancy-induced hypertension, PTSD, anxiety, phobias, and sleep disorders. So how does one go about trying resonant breathing? Of course, the best way is to find someone with the expensive equipment and the training that Doctors Gevirtz and Lehrer use to calculate the exact breathing rate that maximizes respiratory sinus arrhythmia and heart rate variability. The Biofeedback Certification International Alliance lists qualified practitioners on their website, and they offer training programs. For do-it-yourselfers, you can buy a Bluetooth-connected chest strap that measures your heart rate and can also be connected to a cell phone. There are many apps that will use the data to calculate the heart rate variability, like Elite HRV. You could then sit in a quiet room and breathe slowly, looking to maximize your heart rate variability. The technique that Dr. Gevirtz uses for finding the resonant breathing frequency is to start at 7 breaths per minute, then go down by half breath per minute steps and gradually decrease the respiratory rate until the heart rate variability goes up. Then continue to go down in half breath per minute steps until it drops off again. The rate just before the heart rate variability drops off is used as the resonant frequency. There are many free apps for cell phones that will allow you to select a breathing rate and then give you visual and auditory clues to breathe at that rate. Dr. Gevirtz prefers, however, to correlate this with a polygraph featuring respiratory rate, skin temperature, and skin conductance channels when possible for greater accuracy. The nonprofit HeartMath Institute spends several $1 million a year researching and teaching breathing exercises based on heart rate variability and slow breathing, using 2 different heart rate monitoring devices that they produce, one of which connects to a laptop and the other one to a cell phone. Though their approach to calculating the resonant frequency is slightly different, Dr. Gevirtz feels that their devices usually arrive at the same rate he does. In many studies that I looked at, they used a control group that was breathing at 1 breath per minute faster than their calculated resonant frequency. And this group often received significant partial benefit compared to the sit in a quiet room and breathe slowly group. So even a less than perfect slow rate is very likely to give you some benefit. I hope you'll add slow breathing to your health armamentarium. It's been proven safe for millennia by meditating monks, and the cost is minimal. Why not get out there and exercise your parasympathetic nervous system, just like you do the rest of your body, so you can experience the best health of your life?